Hi everyone, I'm Doug Black, Editor-in-Chief at Inside HPC. This week we're at the SC23 conference in Denver. And with me now is AWS. We have Debra Goldfarb. She is Director of HPC Products and Strategy. And we have Brendan Bouffler. And we're demonstrating and talking about the Research and Engineering Studio, which AWS announced this week. And Debra, I understand this is a self-service portal. Tell us what it's all about.
Thanks, Doug. So let me just kind of step back for a minute and tell you why we built this product and why it's important. Okay, yes, it is a self-service portal for researchers and engineers to really enable a broader set of customers and users and researchers and innovators access to advanced computing without having to know all the inside of what goes on with supercomputers or clusters. Okay, so. The world is full of ideas are democratic, but access to computers is not. And it's really been a driving vision of our organization to invert that problem, right? So how do we create tool chains and capabilities and services that really enable a broader set of, people to have access to this incredible infrastructure? As someone once said, exascale for everyone, right? That's not really what we're talking about here, but this idea of how do you open doors to bigger compute. So we announced Research and Engineering Studio, which is a self-service portal that really brings together the best of workflows and creating collaborative infrastructure to support researchers and engineers across the spectrum. I have with me here my very close colleague, Brendan Bouffler, who I'm going to ask a bunch of questions to show you some cool stuff in the demo. Awesome. Okay? I call him Boof, by the way, so we're going to call him Boof for this. Okay, so Boof, tell us what you got here.
Yeah, so RES is all about making it easy for administrators to be able to deploy quite complex workloads in a very digestible way for researchers and engineers. So, the researcher and engineer end user inside an organization like an enterprise or a research lab at a university, they don't need to know anymore all of the details about how to spin up an instance, make it visualization capable, choose the right instance type, get the right operating system on there, install software packages. They can actually just select from a menu of different instance type and different software stacks that have been offered to them by their administrators. And then they can come over here and they can actually have these visual sessions that they can launch straight out of a browser tab. And in fact, when they launch these browser tab sessions, it opens up another browser tab. So what happens is when they actually open up one of these visual sessions, it actually opens up a complete visual desktop inside a browser tab. So, it's interesting. This is the same kind of technology. In fact, it's the same pixel streaming technology that Netflix uses for their, for their editing suites. All of their editors all over the world are editing their content in environments just like this. So we're delivering the same kind of capabilities for researchers and engineers. Anyhow, as you can see, so they can have these complex desktops. These can have complex software stacks involved in them. And then it also gives the administrator sort of a control panel view of the entire environment. So they can manage the entire environment for an entire organization. They can break resource usage down by project, and they can actually allocate all of that out to users in different groups in the company who are connected to the projects through an Active Directory authentication system.
So Boof, lots of researchers, I hear from them that managing their project cost is an extremely complicated thing and very stressful for them, specifically when it comes to the cloud. What have we done here in Research and Engineering Studio to mitigate that problem?
Everything inside Research Engineering Studio is based around, resources belong to projects, and so do users and groups. They are attached to projects. So that actually means we can actually track the cost for all of the resources down to the project level. RES also interacts and integrates with AWS budgets, so that an administrator can actually set a budget for a project and actually set alarms that trigger when they actually go over their predefined budget levels. And that could be a predefined budget level for a week or a month or a day. And it can actually allow the administrator to actually just start to get a bird's eye view of what the spending looks like and actually start to get a control over what's getting used in the organization. It can also stop users from spending any more once a budget limit's been hit.
So this means end users are really accountable for productivity, engagement, because they're really being tracked.
The best thing about this is it's not just the accountability and controlling the users. It's actually unleashing the users so they can actually self-service all of this cloud capability really extensively without actually having to go back and ask for permission each time they do that. They've got a budget boundary box that they get to work in, and as long as they're working inside that box, they're free to come and go as they please, spin up workloads when they need them, put them to sleep when they don't need them, and it means that they can actually get a lot more work done, with much more agility, much sooner.
It's easy to forget this point, but coming onto AWS Cloud, you're accessing really advanced and new, updated technology, as opposed to on-prem where you have a life cycle to go through with the on-prem technology.
Exactly. I think that's one of the key value propositions of HPC on AWS, is that we are always advancing the curve in terms of innovation, new processor types, the continued advancement of our internal network, EFA, and it's really a very, very, very high value for researchers and engineers because it truly unleashes their creativity in ways that they could not imagine before.
What are examples of some of that advanced technology that you offer on AWS?
So we have our own silicon that we develop. So Graviton, Inferentia, Trainium, all of the investments we've made here through our Annapurna acquisition have been really, really paying dividends. We have incredibly performant infrastructure, through Graviton, and they're on our 3rd generation. We actually have an HPC instance around Graviton. I've been looking at some of the results, and it's actually quite stunning how performant that infrastructure is at a much lower performance per watt. So we're really seeing excellent sort of green qualities, sustainable qualities around that processor as well.
Excellent. Now, can you show us what the end user would see?
So the end user comes in, their experience is typically going to be driven from this screen when they come in. This is actually where they get to see the sessions that they've already established. Some of these will be turned on, some of them will be turned off. And at any point, so you can actually see one down here. This is one that's being provisioned right now. And there's, they get to choose from Windows and from a range of Linux distributions, as well as the software stacks that the administrators define for them to use on those distros. And then it's just as easy, they can look at this thumbnail view, and these are actually live session thumbnails of what's going on those machines that are up right now. And then when they can go in here and they can actually launch to connect to one of those, and that'll actually bring them straight over to a screen like this, that, like I mentioned before, is actually inside a browser tab, but this is a full interactive desktop session. You wouldn't even know it was running inside a browser tab. And now they're actually, using the power of the cloud. And this could actually be, these can be very architecturally powerful systems, right-sized for the job, matching the software that's been built to run on that architecture inside it.
So Brendan, tell us how this encourages or nurtures collaboration.
Right, so in most scientific and engineering work groups, collaboration between peers is actually super important. In the post-COVID world, lots and lots of people are working in either remote locations, or we've just got very large distributed teams across geographies. So being able to share a desktop is really quite powerful. Now, it's always been possible to do those kinds of things, just desktop to desktop, like we all do with our Zoom call sessions when we're interacting with each other in the office. But the thing that Res actually brings to the party is the ability to do that in a very, very high fidelity, high performance streaming protocol, particularly when you're working with large data sets. So the massive data sets that customers are working with in the cloud, with these instances, you can have a very powerful EC2 instance connected, doing some analysis on a very large data set in the back inside the cloud. But through Res, because of this desktop streaming, you're basically, you're as good as being there. It's as good as being in the data center without the air conditioning blowing up your leg and keeping your legs too cold. But the other side of this is you can share a desktop between collaborators, and then you can actually have both collaborators, and they can be geographically quite a large distance apart, not just sharing a desktop, but sharing a mouse and a keyboard on the same desktop. So they're now actually interacting directly with each other over the design or the aircraft wing that they're playing with, or the molecule that they're inspecting, or the drug they're designing. So it's a much more engaged, tightly coupled collaboration engagement than you can get with any other kind of technology.
Okay, so thanks so much for your time. We've been with Debra Goldfarb and Brendan Bouffler at AWS talking about the Research and Engineering Studio, and thanks so much for your time.